Welcome to an introduction to economics, brought to you by Parkbench Tutors and narrated by David Hopcroft. For more information about Parkbench Tutors, please visit parkbenchtutors.com. This is the second short podcast about firms. Our studies have considered a perfectly competitive market. Let us remind ourselves of what we mean by this idea. There are many buyers and sellers, so that an individual cannot really influence the market. New firms are free to enter the market, existing firms are free to leave the market. There is mobility of factors of production, perfect knowledge, and the product is homogeneous. If these assumptions operate, then the market can lead to the Pareto optimal allocation of resources. Since each firm would be small compared to the relative size of the market, we can regard the demand curve as perfectly elastic with a downward sloping curve. The firm can be regarded as a price taker, since if it tried to sell above the market price, it would sell nothing. A perfectly competitive firm in a perfectly competitive market would have an equilibrium price for good X determined by the demand and market supply curves DD and SS on the diagram. The equilibrium price will be P1 and the equilibrium output will be Q1. A firm earning above normal profit with a perfectly elastic demand curve will sell goods at market price where price P equals TR, total revenue, divided by Q, quantity. The price P equals average revenue, AR. Since the firm gets a constant price, MR must also be equal to price. So AR is equal to MR. Now let us map this. Here we are then. The map for competition for a firm with above normal profits. We want to find that point which will show the equilibrium quantity. The MR equals MC rule says that it will be where the MC curve cuts the MR curve from below. This is at point A, where the level of output is Q1. At this point, the price P1 is also equal to MC. The average cost at output Q1 is Q1B. Total cost is equal to average cost multiplied by quantity. So I can show my total cost as being the rectangle OCB Q1. I have shaded this to show it more clearly. An important point to bear in mind here is that the cost curves already incorporate an allowance for normal profit. At the equilibrium level of output, where the marginal cost curve cuts the marginal return curve, the total revenue is represented by the area of the rectangle OP1 AQ1. Again, I have shown this area by shading. The firm is therefore earning revenue above total costs. Here I am showing how much revenue has been earned as above normal profits. I have shaded the rectangle P1 A, B, C. The effect of having above normal profit in an industry is to attract new firms into the industry. This will result in increased production, so output is increased and the price is pushed back down. Eventually the above normal profits will be eliminated. We are now going to look at another perfectly competitive firm. We start once again by showing that the equilibrium price and quantity are determined by the intersect of the demand and supply curves. So Q1 is the quantity produced, and this will be sold at price P1. Now consider what is happening for a firm making a loss. The average total costs, ATC, are above average revenue, AR. The firm is not covering its opportunity costs. The intersection of the MR and MC curves is below the average total costs. This intersection shows the loss minimizing output at Q1. At the loss minimizing output point, the average total cost is equal to BQ1, which is greater than the average revenue, AR. The loss per unit of output is now equal to BA. The total loss is represented by the area of the rectangle P1 DBA, which I have shown shaded for you. Should the firm now close down? Well, with output Q1 and price P1, the price is still above average variable costs. So variable costs and part of fixed costs are being covered, and this is why a firm may continue to produce in the short run. To maximize profit, the perfectly competitive firm produces at the intersection of the marginal cost curve with the marginal revenue curve, provided this is above a shutdown point, that is, above the average total costs. At price P1, the firm offers for sale the quantity Q1. If there is a rise to P2, the quantity supplied rises to Q2. At P3 it would be Q3, and so on. The short-run supply curve is the marginal cost curve that is above the variable cost curve. In other words, where the short-run industry supply curve is simply the sum of the marginal cost curves of all the firms that comprise the industry. The marginal cost curves for firms A and B are shown, and then the sum of the marginal cost curves. The sum of the short-run supply curve for the industry and the market demand curve for good X will determine the market price. If above normal profits can be earned, then new firms will be attracted to the industry, so the above normal profit will eventually be eroded by competition. If typically the firms are making losses, then some firms will leave the industry, the result being that prices will rise until normal profit gets restored. The equilibrium position will be where only normal profits are made. This is at price OP1 and quantity OQ1. It is the point where the LRMC, long run marginal cost curve, intersects with the LRAC, long run average cost curve. This will be the lowest point on the LRAC curve. At this point, price is equal to both marginal cost and average cost. Perfect competition in a competitive market structure should lead to the Pareto optimal, which means efficient allocation of resources. If this is so, then we should be able to demonstrate that the three marginal conditions for Pareto optimality are all met. Let us return to our food and cloth model with the labour and capital factors. The first point of interest for capital and labour as factors of production is where the isocost line is tangent to the isoquant. At this point, the slope is given by pk divided by pl, where pk is the price of capital and pl is the price of labour. The first Pareto condition can be expressed by stating that the marginal rate of technical substitution of one factor for another must be equal for all goods. If food producers a profit maximizers, then the marginal rate of technical substitution for food, MRTS food, will be equal to pk divided by pl. If the cloth producers are also profit maximizers, then the marginal rate of technical substitution for cloth will also be pk divided by pl. So MRTS for food equals MRTS for cloth, which satisfies the first Pareto condition. The second Pareto condition is that the marginal rate of substitution for every pair of goods should be equal for all individuals. So the point of interest is where the budget line is at a tangent to the indifference curve. At this point, the slope is given by PC divided by PF, where PC is the price of cloth and PF is the price of food. Since A is a utility maximizing consumer, then the marginal rate of substitution of food for cloth for individual A is PC divided by PF. Since B is also a utility maximizing consumer, then the marginal rate of substitution of food for cloth for individual B is also PC divided by PF. So MRSA equals MRSB. The marginal rate of substitution for A is equal to the marginal rate of substitution for B, which satisfies the second Pareto condition. The third condition is that the marginal rate of substitution should equal the marginal rate of transformation for all pairs of goods. The map shows the production possibility frontier and the marginal rate of transformation. To move from point A to point B, delta C of cloth is given up to produce delta F of food. The marginal rate of transformation is the slope of the production possibility frontier. MRT is equal to MC for cloth divided by MC for food. The marginal rate of transformation is equal to the marginal cost of cloth divided by the marginal cost of food. Moving along the frontier leaves the total cost unchanged, since all resources are fully employed. So delta C multiplied by MC for cloth must be equal to delta F multiplied by MC for food. Rearrange that. Delta F over delta C equals MC cloth over MC food, which equals the marginal rate of transformation, MRT. Now, since MRS for A is equal to MRS for B, which is equal to PC divided by PF. If MRS is to be equal to MRT, then PC divided by PF must be equal to MC for cloth divided by MC for food, which is what we have. So the third condition is satisfied. All three Pareto conditions are then satisfied. However, you should note that this does not mean there will be an equitable distribution. Remember that equity and efficiency are different. This ends our second podcast on firms, brought to you by Parkbench Tutors and narrated by David Hopcroft. Thank you for watching and for listening. For more information about Parkbench Tutors, please visit parkbenchtutors.com.